Okay, welcome to our day 2 of jam preparation chemistry, melting and boiling point. Please get your biro and your paper as you follow up, relax and enjoy the teaching. Okay, today today we'll be looking at boiling and melting point. Okay, now the boiling and melting point, according to what they actually want us to study, is boiling and melting point at regard to pure and impure substances. Okay, so we're going to look at it, which is element, compound and mixtures. Okay, the effect of some factors on boiling points and melting points. So let's look at it, okay, gradually. First of all, what is boiling point? The boiling point of a pure substance, remember, pure substance, okay, is the temperature at which the substance transition from a liquid to a gaseous phase. At this point, the vapor pressure of the liquid is equal to the applied pressure on the liquid. So the boiling point at a pressure of 1 atmosphere is called the normal boiling point. Okay, so I want you to take note of this. It said the vapor pressure of the liquid is equal to the applied pressure is the atmospheric pressure of the liquid, atmospheric pressure on the liquid. Okay, so it's equal. When they are equal, boiling starts at that particular temperature. So that is it. Okay. On the other hand, the melting point is usually defined as the point at which materials change from a solid to a liquid. Okay, so material changing from a solid to a liquid, just like the point at which you melt a candle wax. Okay, melt a candle to its wax. Okay, so liquid wax. So you see that point at which it melts is called the melting point. Okay, now the vapor pressure, for example, is the pressure exerted on the kettle lid by the vapor coming out from the liquid. So you understand what I mean by vapor pressure now, because someone will be asking, what do I understand by vapor pressure? I don't understand vapor pressure and atmospheric pressure. Okay, so I'm going to explain them now. The vapor pressure, for example, is the pressure exerted on the kettle lid by the vapor coming out from the liquid. Okay, so you know that when you are boiling something, for example, there is a pressure that is always attacking the lid, the cover of that particular kettle or pot. Okay, that pressure is what we call the vapor pressure. Immediately open, you see the vapor coming out. Okay, that's the vapor pressure. So when the vapor pressure equals the atmospheric pressure, now let's look at atmospheric pressure. Atmospheric pressure is that pressure within the Earth's atmosphere, commonly known as atmospheric pressure, within the Earth's atmosphere. So atmospheric pressure decreases as at higher altitude and increases at sea level. So that means the higher you go, the lower the pressure. Okay, but the lower down you go to the earth, the higher the pressure. Okay, so when you are going up, the atmospheric pressure decreases. When you are coming down, the atmospheric pressure increases. So at the top of a mountain, the pressure is lower such that the liquid starts boiling at a lower temperature than obtained at the base of the mountain. So that is it. Now, how do we determine boiling point here? Okay, what are the factors? What are the things that you should look out for in determining boiling point? One, their functional group. The functional group of a compound, okay, also helps to determine the boiling point. I will explain that one later. Then intermolecular forces and shape and symmetrical of particles. These are things that determine boiling point. Adding impurities to water, for example, will increase its boiling point and decrease its freezing point. So when you add impurities to water, you're expecting that the temperature at which it will boil will be above 100 degrees Celsius, which is for pure substance, of which water is a pure substance. Okay. Now, if the external pressure is less than 1 atmosphere, external pressure is less than 1 atmosphere, the boiling point of the liquid will be lower than the standard boiling point, or which will know that if atmospheric pressure decreases, then definitely the boiling point will do what? Will be lower, or occur at what? A lower temperature. So that is it. Okay, so we're going to look at this. Some elements and the highest element that has the highest melting and boiling point. Now, Tungsten is a metal, okay, has the highest melting, remember, melting, I didn't say boiling, melting point as an element, okay, while xenon has the highest boiling point, okay. Xenon is Ze is for call it a noble gases, so it's a gas, so it's actually a gas that has the highest boiling point because it has a higher molecular mass, okay, has a higher molecular mass than helium. Helium, it has the lowest boiling point as a gas because it has what we call a lower molecular mass, and because it's weaker, has a weak force of attraction, okay. So elements with lower molecular mass have fewer numbers of electrons and weak van der Waals forces because between the molecules usually have a low boiling point. For example, let's look at halogen families, okay. The boiling point increases in this order, okay. You see fluorine, chlorine, bromine, and iodine, okay, which means at this a single element they are, fluorine will have the lowest boiling point, while iodine will have the highest boiling point, okay. But when it occurs as hydrogen halide is no longer a single bond, a single element. Hydrogen halide means that it has now formed a hydrogen bonding with the halogens, okay. So hydrogen halide, the order is in this way: HF, that hydrogen fluoride, hydrogen bromide, and hydrogen iodide, and hydrogen chloride, meaning that hydrogen fluoride has the highest boiling point now. You seen it? Why back has the back, that's HCl, has lowest boiling point. Are you seeing it now? So because of what? HF being hydrogen fluoride is more fluorine is more electronegative than chlorine. So because of that, okay, it attaches itself more to the hydrogen, and it will now require more forces to break them up. So that more forces that are required to break them up will contribute to its what? Higher boiling point, okay. Now let's look at water. Water has the highest boiling point, followed by what? Followed by hydrogen fluoride, and then ammonia, okay, because of the electronegativity that I told you before, okay. The one that has the highest electronegativity, water -2, hydrogen fluoride -1, then ammonia comes in, okay. So boiling point is highly dependent on the intermolecular forces of a compound. Compound with stronger intermolecular forces, larger masses, and less branching will have higher boiling point. Yes, okay. Examples are ionic bondings, sodium chloride. Okay, see that they have always have a high boiling points. Okay, they have highly boiling points. Then larger masses also have highly boiling, like we discussed earlier. Then less branching. Less branching is for hydrocarbons that have straight chains. The straight chains will have a high boiling point compared to the branch chains. Those of you that have done organic chemistry will understand what I'm saying. So that is it. Okay. Next one is metallic character trends. The boiling point increases across the metal from left to right, within a periodic period, because the strength of their metallic bond increases from left to what? Right. You see it? So it actually increases across the metal from left to right in the periodic table. Now, N-pentane is a compound with a high boiling point. Carbon in the form of diamond has a very high melting point. So this one has a high boiling point, and pentane, while diamond, we know that diamond is the hardest known substance. Okay, has a high melting point. Okay. Now, boiling point is highly dependent on the intermolecular forces of a compound, like we said before. Compound with higher intermolecular forces, large masses, and less branching will have high boiling point. Okay. Now, hydrogen sulfide desires having a relative molecular mass of 34. Remember, in terms of higher molecular mass, okay. So but in this concept, we'll now see the reason why, despite hydrogen sulfide having a higher molecular mass of 34, we still have a lower boiling point compared to water that has 18. Okay, so 34 has it's a molecular mass of 34 has a boiling point lower than that of water, relative molecular mass of 18. Then oxygen are more electronegative, you see. So the reason why is because oxygen is more electronegative. So that means it attaches itself firmly to the hydrogen bond, okay, and require more energy to break them. So that is why it has a high boiling point compared to sulfur. Okay, so is more electronegative than sulfur, therefore have strong hydrogen bond than Hs. So more energy is required to break the hydrogen bond in water. Okay, now let's look at the difference between evaporation and boiling. Capital. So 1, boiling occur throughout the liquid. Yes, occur throughout the liquid. If you open your pot, you see how the kettle, the water there is boiling, or how your food boils. Okay, so you see that boiling occur at throughout what liquid, both at the bottom, the top, and the center, anywhere. But evaporation occur only at the surface of the liquid. You see, there's only the surface that you see gases leaving the surface of the liquid. Number 2, boiling occur at a particular constant temperature. Yes, it has a particular temperature before boiling actually starts. Okay, but evaporation takes place at all temperature. Okay, number 3, boiling has no cooling effect. It has no cooling effect, but evaporation has a cooling effect, because evaporation has a way of what they take away they absorb the heat and take it away. They absorb the heat and take it away. Because of that, it has a cooling effect, just like you are using a spirit. You know a spirit, okay, you pour it on your body, you see what happens. You observe a cooling effect because it absorbs the heat within the skin, within the environment, and takes them away. So because of that, you observe a cooling effect. Then it is exothermic, being the boiling. Exothermic means it absorbs it gives out heat to the surrounding, and while evaporation is endothermic, that means it absorbs heat and takes away. Because of that, is an endothermic. Then number 5, occur using external source, yes, of heat. Boiling requires external source of heat, like flame, okay, fire, or so on and so forth. But evaporation occurs using internal energy. Internal energy, just like a spirit. You see, it doesn't have a source of heat, but you see that you observe a cooling effect because it uses what we call internal energy. Okay, and it is spontaneous, while boiling is not what spontaneous. Then number 6, it said bubbles are observed in boiling, but in evaporation, bubbles are not observed. Okay, number 7, boiling is not affected by humidity, while evaporation is affected by humidity. Yes, if the place is humid, that means evaporation might slowly take place. Just like, for example, in outside in the Western world, you see that they still cook their food despite the boil their water, cook their food despite the temperature, okay, the lower temperature they have over there. Okay, so that is it. Then boiling is a fast process, while evaporation is a slow process. So that is it. Okay, so please tell your friends, tell your classmate that something is going on. Okay, this is our day 2, sorry. Okay, these are day 2. We said we have 60 days to get ourselves fully prepared for the exam. So this is our day 2. So this is for the day 2. So we take your past questions if you actually have an answer question that has to do with boiling and melting points. Okay, and I believe you'll be able to answer most of the questions. Remember, like I told you, ionic compounds always have higher boiling points, like sodium chloride and etc., while covalent compound that has a van der Waal, okay, has van der Waal bonding, always have a lower boiling point. Please take note of that. Okay, see you in the next class. Thank you.